SolidWorks Simulation, Lecture 8, Part 1, Steady State Thermal Analysis. Open a part file. On XY plane, enter sketch mode. Draw a square, 50 by 50. And extrude to 5 millimeters. And open sketch on the top surface. And turn the surface. Draw a square, 10 by 10, maybe 5 by 5. Okay, and extrude to 45 millimeters. 45. So that the height will be 50 millimeters. And now I will choose the curve-driven pattern. The first curve will be this line. And make sure that you choose the line adjacent to this feature. And I will make it 5 instances. And I'll toggle the direction so that it appears in yellow. Preview. And for the second direction, I'll choose this line, not this line. The line adjacent to the feature. And also, I'll make it 5 or 6, maybe 7. Okay. And I'll click on check the equal spacing. It is too crowded. So I make it 6, 5 by 6. Okay, 4 by 6. 4 by 5 array. Okay. So this is the heat sink, the model. I'll save the model on desktop. And I'll load the software. SolidWorks Simulation. And load the toolbar. And this is the toolbar. And I finished with the second preparing step. I'll open a study, a thermal study. Now, I have the third preparation step, which is to identify, to arrange the icon. And this is convection heat transfer, and this is power, heat power. So these are the two icons that I need, so I don't have to arrange the icons. So before I proceed with other processes, actually I have finished with the first step of CAE analysis by generating the model, 3D model, and opening a thermal analysis. And now there are two types of thermal analysis. The first is steady state, which is the default. And now in this example I will use steady state. In the next example I will use transient thermal analysis. So I'll leave it as steady state. Steady state means the time goes infinity and the system becomes thermally equilibrium. So now equilibrium means the temperature of each part will not change by time. So first of all, I'll define material. This is the second step. And I'll choose aluminum alloy. General heat sinks will be 60, 61 here. aluminum alloy 6061, and I'll generate mesh with default mesh size and hide the mesh. For the boundary conditions, for steady state thermal analysis, we don't need to apply initial condition since the time goes to infinity and the initial condition will dissipate through time. So I will only apply a heat power, and I'll give it 28 watts on this surface, which is the power for a CPU in the computer. Now I'll apply a convection here because most of the students will run the project right now because they don't see the air. Actually, whenever there is air in contact with the heat sink, you must apply convection on it. So I'll choose all exposed surface except for the surface that is connected to the CPU. It is where I apply a heat source to it. So these are the surfaces that I will apply convection on it, and the convection constant coefficient will be 10, and this will be a stagnant air, still air condition, and the convection coefficient will be 10, and the ambient temperature I will choose Celsius, and this will be 25 degrees Celsius, and I go back to SI unit, and it's 298.15 degrees Kelvin. So I will define the convection condition will be 10, the coefficient of convection, which is the stagnant air, still air, and I'll define the ambient temperature of 25 degrees Celsius, and then I'll run the program. And it is because the icon is so huge that I'll change the icon into a smaller icon. Okay, so the convection icon is smaller. Now I'll tap, first of all, I'll edit the definition so that the temperature will be Celsius, and the number will be floating point format with 3 digits under decimal. So now it is easier to read, and I'll probe at this point, and it'll give me 152.8 degrees Celsius. So this is the temperature at infinity time. So I'll click it here, and this will be the temperature. So you can see from here that when the time goes to infinity and the thermodynamic system goes to steady state, the temperature become homogeneous, and the temperature will not change through time, and the temperature on this spot will be 150 degrees, and we will compare it with the transient thermal analysis later.